Welcome to Coder Station.
So, welcome back fellow coders to Coder Station, your go-to destination for all things related to programming. I'm thrilled to have you here for the second video in our Java programming series. Today, we'll be diving deeper into the fascinating world of Java programming and learn about the most important components of Java programming, that are JVM, that is Java Virtual Machine, and JIT, that is Just-in-Time Compiler. I'll tell you about it more in the further video. So, in this video, we'll mainly focus on JVM and its crucial role in executing Java programs. If you have ever wondered what happens behind the scenes when you run a Java code, this video is perfect for you. So, exactly in this video, we'll understand that what is JVM, what does it do, and why is it such a fundamental component of Java programming language. In this video, we'll answer all these questions and more. We'll start first by understanding the concepts of Java Virtual Machine and then how they enable Java platform independence. We'll then explore the architecture of JVM and its main components and the functions in executing Java bytecodes. So, let us start by understanding what is JVM. So, JVM or Java Virtual Machine, it acts as a platform that executes Java bytecodes, making Java programs independent of specific hardware or operating system. The JVM manages memory, handles garbage collection, and optimizes code to ensure efficient and reliable execution. In simple terms, the JVM serves as a bridge between your Java code and the underlying system, enabling portable and cross-platform development. Then, what is the main use of JVM? JVM is specifically responsible for converting bytecode to machine-specific code, since the machine cannot understand the human language or the codes written by us. JVM converts them into the language that a machine can understand and it can run on it. And it is necessary in both, that is JDK and JRE, that is Java Development Kit, and in JRE, that is Java Runtime Environment. In both of them, it is very necessary. It is also platform dependent and performs many functions including memory management and security. So there are actually many, but these are the key advantages of JVM. First is platform independence. Platform independence, as the tagline of Java says, that write once, run anywhere or run anytime. With this, we can understand that JVM allows Java programs to be executed on any platform that has a compatible JVM implementation. Java source code is compiled into platform-independent bytecodes which can be run on any device on any operating system that has JVM in it. Then second is memory management. The JVM automatically handles memory allocation and garbage collection for Java programs. It manages memory usage efficiently, preventing memory leaks and memory-related bugs. Developers do not need to manage memory explicitly, making Java programs more robust and reducing the risk of memory-related issues. Then, the third key advantage of JVM is strong ecosystem. JVM has a vibrant and extensive ecosystem with a wide range of libraries, frameworks, and tools that are available for Java developers. This rich ecosystem accelerates development, enabling developers to leverage pre-existing solutions to solve problems that are very complex, and it helps to solve these problems efficiently. Then the fourth one is multi-threading and concurrency. So the JVM supports multi-threading, allowing Java applications to efficiently handle concurrent tasks. Java's built-in thread management and synchronization mechanism simplifies the development of multi-threaded applications. Then this is a very main key advantage of JVM, that is, it supports the backward compatibility. JVM maintains a strong commitment to backward compatibility. The Java programs that were written in the JVM versions that were older can also be run on the newer versions. JVM versions without requiring significant modifications, ensuring long-term support for Java applications. The Python programming language doesn't support backward compatibility, like the new Python codes are only runnable on that version itself, and the old ones are only runnable on the old versions. We cannot run them on the new versions. This is a very drawback of other programming language, but Java is exceptional. It allows us backward compatibility, and also it supports for multiple languages. While Java is most well known for the JVM, the platform also supports other languages such as Kotlin, Scala, Ruby, Clojure, and etc. This enables developers to choose the best language for their specific project while still taking the benefit from the JVM's advantage. So now, I'll tell you about the architecture of JVM, a simple one that will help you understand of how JVM actually works. First, in this diagram, we can see that on the topmost square there is written that there is a Java code. This is the Java code that you will write. In the further video series, I'll teach you everything about how you can write your Java code to executing your Java code on your own computer, despite of any computer you have. So at first you can see that it is written that Java code and in bracket .java. What does that mean? So which Java code you will write, whichever Java code you will write, will be saved with the extension of .java. Then further it will be compiled using a command. I'll also teach you and make you understand of how any command actually works in Java programming language. So the JavaC compiler compiles the Java program and then returns us a .class file, that is a file that has the bytecode which a machine can understand. Then further, any operating system, whether it be a Windows operating system, Linux operating system, or Mac operating system, if it has JVM implementation, it can run this Java program despite of any operating system you have. Then further, I'll tell you about what is JIT compiler. You may have been confused about what is this compiler and how does it actually work. Then I'll tell you about JIT compiler. The JIT stands for just-in-time compiler. It is a component of the runtime environment that improves the performance of Java applications by compiling bytecodes to native machine codes at runtime. There are three types of JIT compilers. They are pre-JIT compiler, econo-JIT compiler, and normal JIT compiler. I'll tell you about them in detail and the difference between them. So at first we have the pre-JIT compiler. The pre-JIT compiler is a compiler that compiles the entire code into the native code completely. What does that mean? That it completely, like the source code, is getting converted into the native code in a single compilation cycle. This is done at the time of deployment of that application. In econo-JIT compiler, it compiles only those methods that are called at the runtime. However, these compiled methods are removed when they are not required. This helps in saving space. And the normal JIT compiler, it compiles only those methods. It also compiles only those methods that are called at runtime. These methods are compiled at first times when they are called, and then they are stored in the cache memory of the computer. And when the same methods are called again, this compiled code from the cache is used for execution. This improves the time in execution of the code. Then we have the advantages of using JIT compilation. The first advantage is performance boost. The JIT compilation allows the JVM to optimize the code based on the actual runtime environment, resulting in faster execution compared to interrupting bytecodes. Then adaptive optimization. What does this mean? The JIT compiler can make runtime decisions and apply different levels of optimizations based on the program's execution behavior. This adaptive approach leads to better performance for frequently executed code paths. Then platform independence. This is a very key feature, as you all know about it. Despite generating platform-specific native codes, Java programs remain platform independent at the source level, thanks to the intermediate bytecode representation. Then early error detection. This is a very important feature that Java has provided. that whether there is an error in the Java program, we can detect it very early so that it cannot create, or it helps us in identifying the errors and solving it in the early stages of application development. It can detect certain errors during the translation program, that is the compilation program, catching them before the code is executed, and also saves our memory and time. Then dynamic class loading. The JVM can dynamically load classes at runtime, allowing for more flexible and dynamic program behavior. And the next is hotspot optimization. Modern JVM implementations like Oracle's Hotspot JVM use advanced optimization techniques that dynamically identify hotspots. So, what are these hotspots in the code? Hotspots are frequently executed codes that are executed a lot of times, and in these codes it means that they are very necessary. So it dynamically identifies these hotspots and applying aggressive optimizations to these areas. So in this process, because of this hotspot optimization, it enhances the performance of executing the code. Now I'll tell you about how Java programs actually work with the help of a simple small block diagram. So as you can see in this block diagram, the Java programming starts as a source code. A source code is a human readable code written by the developer using a text editor or in an IDE. What is an IDE? It is an integrated development environment for Java programs. In the further video series, I'll tell you about how you can install IDE in your own computer. Then these source codes are sent to the Java compiler. This Java compiler translates the source code into and platform independent bytecodes, that is, into class files. This compiler or this step is responsible for checking the syntax errors and generates bytecode instructions. Then these bytecodes are sent to the Java virtual machine, the JVM. The JVM acts as a bridge between the platform independent bytecodes and the underlying operating system. JVM reads and interprets the bytecode, providing a uniform execution environment for Java applications. Then the JVM sends the code into the native language to the operating system. The native machine codes generated by the JIT compiler and JVM together, they are executed on the operating system on your hardware itself, despite of what operating system or what hardware you have. If you have JVM implementation, the code will run on it. Then these codes are sent to the operating system. These codes are not the old source codes. These are the native machine codes generated by the JIT compiler and JVM together. These codes are executed by the operating system on the underlying hardware. The OS handles the system resources, memory, and the low-level operations necessary to run the Java program on the target platform. And then, in the end, what we get is the result. The Java program runs on the operating system utilizing the resources provided by the JVM and the underlying hardware, and it produces the desired output or performs the intended task as defined in the original Java source code. So with this, I'd like to wrap up this short video about what was JVM and JIT in detail, as these are the very important components of the Java programming language. I hope that this video has shed light on how Java's unique architecture powered by the JVM and JIT compiler provides the magic that makes Java truly write once, run anywhere. Understanding these concepts is not only essential for aspiring Java developers, but also empowers you to craft efficient and powerful applications that can thrive on any platform. We have barely even scratched the surface of Java's vast potential, and I encourage you to continue exploring this incredible programming language. Whether you are interested in web development, mobile apps, enterprise solutions, or anything in between, Java's got you covered. If you found this video insightful and want to continue your coding journey, don't forget to hit that subscribe button and ring the notification bell to stay updated on our future Java tutorials and exciting content here at Coder Station. So, thank you for being a part of our vibrant community of passionate coders. Your support motivates us to keep producing valuable and engaging programming resources. If you have any questions, feedback, or topics you'd like us to cover in future videos, drop them in comments below. We love hearing from you. Also, in the upcoming video series, I'll tell you about how you can install JVM and IDE in your own computer and how you'll begin the journey of Java programming by writing your own first Java program. And there is much more from basics to all the complex stuff in Java. So, with this, we are signing off. Remember that learning never stops in the world of programming. Embrace new challenges, keep experimenting, and most importantly, enjoy the process of mastering Java and beyond. This is Coder Station, where knowledge meets inspiration, and we can't wait to see you in our next coding adventure. Until then, happy coding!